Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. In 2006, scientists from the Holocene Impact Working Group published evidence of an extraterrestrial impact on the Indian Ocean 4,800 years ago. The splash in the ocean created a giant wave 180 meters high that dredged the sea shelf of Madagascar and deposited material from the ocean floor along the shore as wedge-shaped sediments called chevrons. The position of the impact was determined by triangulating chevrons in Western Australia, India, and Madagascar, but the claim that these chevron dunes are due to tsunamis has been challenged by geologists. The scientists proposing the extraterrestrial impact recognize that chevrons can be produced by mega-tsunamis originating from point sources such as landslides, impact craters, and volcanic explosions. Chevron dunes are not oriented in the direction of the prevailing wind. They can form where there are no beaches, and they contain grains larger than 2 millimeters in diameter, which are not easily carried by the wind. The research by Dr. Dallas Abbott and 5 co-authors identified the source of the Madagascar tsunami as the 29-kilometer Burckle crater, which contains meteorite fragments, impact glass, oceanic mantle fragments, and impact spherules. A second study investigated the possibility that the Mega-tsunami chevrons along the southern coast of Madagascar were caused by 2 or more major Holocene Indian Ocean cosmic impacts. The study used many resources, including the archaeological record, satellite images of the chevrons, deep-sea cores, seafloor bathymetry, and physical examination of the Madagascar chevron deposits. Burckle crater is an undersea feature hypothesized to be an impact crater by the Holocene Impact Working Group. Members of the group suggest that the crater was likely formed by a very large-scale and relatively recent comet or meteorite impact event approximately 4,800 years ago. Burckle crater is estimated to be about 30 kilometers in diameter, and it is 1,650 kilometers east of Madagascar. The crater is 2,620 kilometers from Mozambique in Africa and 5,080 kilometers from Western Australia. Burckle crater is at a depth of 3,800 meters below sea level. An image of the seafloor using Google Earth does not show a clear circular shape for the crater. In 2008, Professors Painter and Ishman objected to the way in which the Burckle crater was identified based largely on chevrons, ocean floor topography, and the identification of foraminifera with fused metals in nearby ocean cores. The professors call this an extraordinary claim and suggest that the chevrons are clearly created by the wind and that the term chevron should be purged from the impact-related literature. Professors Painter and Ishman later co-authored a Requiem paper for the Younger Dryas impact hypothesis in 2011. Professors Bourgeois and Weiss have argued that chevrons are not mega-tsunami deposits, and they also suggest that these V-shaped structures could have been created by the action of wind. These researchers use a computer model to argue that tsunamis do not transport sediments under conditions that could produce chevrons, and that the way in which the waves approach the shore in their model is inconsistent with the orientation of the chevrons in Madagascar. This image shows chevrons on the shore of Mozambique, 60 kilometers northeast of the capital Maputo. The yellow line indicates the direction toward Burckle crater, 2,620 kilometers to the southeast. The chevrons are aligned in the north-south direction, and it is evident that these chevrons are not aligned toward Burckle crater. One would expect that if the impact that created Burckle crater was able to create chevrons in Australia, it should also have created some in Mozambique, which is a lot closer than Australia. This image shows Perth in Western Australia and the location of chevrons along the Indian Ocean. The upper image shows chevrons on a shore 600 kilometers north of Perth. The yellow line indicates the direction toward Burckle crater. The chevrons on this shore are definitely not aligned toward Burckle crater. The lower image shows chevrons 290 kilometers south of Perth that are aligned toward Burckle crater, but it is necessary to question whether an impact 5,080 kilometers away could have created these chevrons, or whether it is more likely that the chevrons were produced by a tectonic event closer to the Australian coastline. The orientations of the chevrons on the Australian coastline converge at an ocean ridge 450 kilometers southwest of Perth. It is possible that an earthquake at this oceanic ridge could have produced a tsunami that created the chevrons on both of the Australian shores. Burckle Crater is very close to several fracture zones along the Atlantic Indian Ridge that separates the African plate from the Antarctic plate. Movement along these plates or fracture zones could create tsunamis. This makes it very difficult to differentiate whether a tsunami was produced by an extraterrestrial impact or by tectonic activity. There is another feature 680 kilometers southwest from Madagascar that aligns more precisely with the Madagascar chevrons than Burckle Crater. I sent an email to Dr. Dallas Abbott pointing out this feature, and she replied, "It is not round, so it is not a crater." However, closer examination indicates that what appears to be an elongated crater could be two adjacent circular craters that formed from a meteorite that fragmented as it traveled through 4,800 meters of ocean water to hit the seafloor. The circular features have diameters of 27 and 24 kilometers. There are many problems associated with the interpretation of the direction of the chevrons and seafloor features. Exploration of the ocean is difficult and expensive, so this is not easy to verify. The Earth Impact Database maintained by the Planetary and Space Science Center at the University of New Brunswick contains a list of confirmed impact structures from around the world. Confirming an impact requires demonstrating shock metamorphism, meteorite fragments, siderophile elements, and other criteria that are characteristic and unique for extraterrestrial impacts. As of 2019, there are 190 confirmed impact structures in the database. Regions that are very cold and difficult to explore, such as Siberia and northern Canada, don't have many craters in the database. The Amazon and African jungles, which are very inaccessible, also do not have any craters in the database. Out of the 190 confirmed craters, only a few are in water. If 70% of the Earth is covered by water, there must be a proportional number of craters at the bottom of the oceans. That would correspond to about 443 craters. Mjolnir Crater in the Barents Sea is a meteorite crater north of Norway at a depth of 360 meters below sea level. It is 40 kilometers in diameter, and it is estimated to have formed 142 million years ago. The meteorite that made this crater was approximately 2 kilometers wide. The crater was discovered when the IKU Petroleum Research Institute mapped parts of the Norwegian continental shelf. The Chicxulub crater off the coast of Yucatan, Mexico, is another example of an impact on water. The crater has a diameter of 170 kilometers, and it is 20 kilometers below sea level. The crater is completely covered by sediment accumulated during the past 65 million years. This impact is considered responsible for the extinction of the dinosaurs. In 1991, Canadian PhD student Alan Hildebrand tracked down the location of the crater by investigating the thickness of the debris covering the layer of iridium deposited by the impact at various locations around the world. Hildebrand finally found the crater's location by using evidence from boreholes made in the Gulf of Mexico by the Mexican oil company Pemex in the 1960s. We have to admire the courage of Dr. Dallas Abbott and her colleagues for facing tremendous criticism while trying to establish new ways of finding extraterrestrial impact craters on the ocean floor. Chevrons may eventually be accepted as a way of locating underwater craters, but finding an impact in the ocean is much harder than finding impacts on land because underwater craters erode easily and get covered with sediment. Statistically, we know that there should be more than 400 extraterrestrial impacts in the oceans, but they may be at depths of 4 to 5 kilometers below sea level. We need to keep exploring to discover the impact history of the Earth. Chevron dunes may provide some hints about the location of extraterrestrial impacts in the oceans. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.